When graphing polynomials or looking at graphs and determining whether or not we could use a polynomial to get such a graph, we need to be aware of some of the common features of polynomial function graphs. So there's two big ones that we're going to talk about here. The first is the graph of every polynomial function is continuous, okay? And continuous, this just means that there are no breaks in the function or no holes, okay? It just continues. We're able to draw it without picking up our pen at all, okay? So here's an example of a continuous function, okay? And here's an example of a continuous function. But this first one is not continuous because as we move along, we have this jump here, and we wouldn't be able to draw this without lifting our pen or pencil and then placing it down again to draw, okay? And then we've got this hole here, so we need to jump over that as well, okay? So this is not continuous, this first one. So this certainly is not a polynomial. The next feature we want to look at is smoothness, okay? So the graph of every polynomial function is also what we call smooth, and this means that there are no corners or cusps. They're nice gradual changes and turns. So here, as we move through here, right here we hit this corner. There's an abrupt change, okay? So that right there is an issue. And then as we continue here, we've got this another thing. This is what we call a cusp, okay? And again, an abrupt change, and then from there on it goes smooth. But these two places are issues. This is not smooth, okay? Not smooth. I should say over here that this was not continuous. Not continuous. And so because it's not smooth, we can say that this is not a polynomial, or I should say polynomial. To be more precise, this is not the graph of a polynomial function. This last one, as we look at this, well, we can certainly draw this with no problems as far as continuity, and it all looks very nice and smooth. There's no corners or anything, no abrupt changes, and so this is the graph of a polynomial. And so this is important to recognize this because, one, as we're graphing polynomials by hand, we're going to know that our graphs need to kind of have these general traits. And second is, if we were say, looking at a curve, maybe we've got a model of something and we want to know what type of function we're looking at. If our model is continuous and smooth, then we know, oh, well, a polynomial might be a good bet there on what type of function to use to model it. Whereas if there's these corners or some jumps, then we know we can't use a polynomial to model that.